Today we will start at Culver Academies, where here we have the Robert Science Lab, where we're currently located now. Over here is where we did our lake control variable, where we can test it for macroinvertebrates and pH levels. Over here we had our lake outlet, which is right here, as well as our lake inlet. Going across the golf course of the academies, we enter Fleet Field. Over here we have our wetland inlet variables. And over here we have our wetland outlets.
A watershed is an area of land that drains water to a common outlet. Watersheds are separated by drains that divide. They can be any shape and size, and this map shows the value of each area: outlets, streams, rivers, and subwash watersheds.
Wetlands are important because they protect and improve water quality. They provide fish and wildlife habitats, store floodwaters during the rain season, and maintain surface water flow during the dry periods.
As we can see here, this is a map representation of where the Indiana wetlands are left. As you can see, there's only a few left compared to past years where there were more. 25% of Indiana was covered in wetlands. Today the percentage has gone down to 4, and it's important to take care of and protect our wetlands for future generations, as well as other aquatic resources.
No, this is one, just one.
One. There's some on the bottom.
2.
3.
Where?
1, 2, 3.
No, there's no 3.
Will you guys, Grace, will you
2.
put this in the bucket, please? Go clean up.
2.
Lakes over time, Lake Max had lost many of its wetlands to filling to development and draining for farming. With fewer wetlands, the lake was affected by fertilizer, blended sediment, and chemicals entering the watershed from farmland and other sources.
Volunteer members, concerned citizens, farmers, and community leaders joined with the Department of Natural Resources, Division of Fish and Wildlife, along with the Division of Soil Conservation, Lake and River Enhancement Program, to build Indiana's first man-made wetland, helping to filter pollutants before they would reach the lake.
Hi guys, as you can see, this is our paper sheet with our results of the lake control, which was the Lake Max. And as you can see here, the dissolved oxygen was of 10%, the pH of 8.5 units, the temperature of a change of 0.3 degrees, total phosphate of 1.8, and a nitrate of 0, and turbidity of 20 units. For the results of the phosphate. As you can see, we still have like the peel there. We're just gonna wait and shake it until it disintegrates.
Types of chemical tests that are used to verify aspects of stream water quality are dissolved oxygen, pH, phosphate, E. coli, water temperature, nitrate, and turbidity.
The way wetlands work is sediment will drop out of the water and become part of the ground layer. This ground layer contains histopause soil, which causes the composition plant or animal material to become part of the soil. Usually the water that flows through this drainage goes by really slow, but because we had a lot of rain yesterday, it's going, as you can see, it's going really fast and there's a lot coming up.
As you can see, guys, we have something moving right there.
So what does that tell us
And right there. We're gonna keep looking for more.
27% of the watershed comes from crop agricultural areas, 14% from pastures, 7% of former row crop agricultural fields, and 15% come from forested land.
Here we have our results taken from the wetland outlet, and we have a pH, which is this one, the green. I don't know if you can see it. This one. That is around 8 because it's very green, and then we have phosphate here, and we put it was 1.5, around 1.5. As you can see here, it's pretty blue. And then for the nitrate, as you can see, it's not clear, like at all. So we put 2 from this table. It's not clear, so we are around this number. And is it nitrate? Yes, nitrate. So about here. Look, there's light there, so you can see better. So these are results so far. We still have to complete the rest, but so far so good.
Okay, Grand. Yeah, I know how to do this. So here, guys, we have this.
Focus.
Yeah, it's moving.
The land areas used for the Wilson Ditch are used for agricultural use, nutrient and sediment loaded into the lake, direct drainage, and tributaries, which come from farms, households, and rainwater drainage.
Why macroinvertebrate are important for water quality testing is because different groups of macroinvertebrate are excellent indicators for human impacts, especially for contamination and pollution levels. The most they have is how they're quite narrow they are for specific ecological requirements. They're very useful as biological indicators in determining the characteristics of aquatic environments to identify the segments of polluted river water and the self-purification of organic inputs is under the process. While chemical tests only give us a snapshot of the area, macro tests give us the stream that sees the consistency of the water quality over time.
So there we go, trying to get the macro test ready. So, Gran, say hi or something. Hi. Well, there is Gran grabbing some samples. Oh my gosh, and he just dropped. Okay, she found it again.
The Wilson Wetland was just constructed for 4 reasons: to treat municipal or industrial wastewater, greywater, or storm runoff. It may also be designed for land reclamation, mining, or as mitigation for natural areas lost to land development.
We know that the wetland is not doing its job if each test tube from the wetland looks really colored, which means that the chemicals like nitrate, pH, and phosphate are really high present in the wetlands. The numbers will be really high too, as you can see in this picture. The higher the number is, the color it's more present in it. And on the other hand, if the wetlands are doing its job correctly, the test tubes will not look so colored since the wetlands are in charge of cleaning the water, and the numbers will be really low too. And as you can see, it goes from like 0 to 8, 5 to 40, 1 to 4, and the lightest, the color the best. So lastly, we have the lake outlet, and the water quality index was good here, which means that the excessive nutrients in the water like phosphate, nitrogen, pH, all of those are not highly present in the water. So if we look back at the diagram from the wetlands and then the lakes, we have first the lake inlet, and then the lake, the wetland outlet, lake inlet, lake control, and lake outlet. And these two had like a water quality of medium, but from the distance that they have to travel to the lake inlet, the water got better, of a ranking of good, so all the excessive nutrients got sink to the bottom, which is good for the lakes. So as you can see, guys, here are chemical monitoring data sheets that we took from all our samples. And if we look back to the map, the first wetland is the wetland inlet, and our results for the water quality index was medium, and same for the wetland outlet, the water quality rating was medium. But for the lake inlet, the water quality index rating was good, and this is because of the distance that the water has to go through, and all these chemicals go to the bottom, so the bad chemicals don't get to the lake so easily. And then for the lake control, the water quality index rating was good too, as you can see here. Same, because all like the water was good in the inlet, so there was nothing to go for. Okay, something that I forgot to say on the previous videos was that for our chemical monitoring data sheets, these ones, we didn't tested the temperature change because this one doesn't affect the water quality. So just to clarify that point.
The Wilson Wetland, the day that we went, was not doing its job. The reason why this happened was because the night before there was a strong storm which overflowed the Wilson Wetland. This caused the wetland to get overflowed and not give enough time for the plants to absorb all the excessive nutrients that it was supposed to, and it did not have enough time to clean the water before it went into the lake.
These chemical tests that we all did include the necessary elements to understand the environmental quality of the water. For example, pH is a figure between 0 and 14 defining how acidic or basic a body of water is along a logarithm scale. The lower the number, the more acidic the water it is. The higher the number, the more basic it is. If the pH of a water is too high or too low, the aquatic organisms living within will die. Dissolved oxygen. It refers to the level of free non-compound oxygen present in the water or other liquids. It is an important parameter in assessing water quality because of its influence on the organisms living within a body of water. Turbidity. It is a measure of a relative clarity of a liquid. It is a optical characteristic of water, and it's a measurement of the amount of light that it is scattered by material in the water when a light is shined through the water sample. The nitrate. Plants use nitrate to build protein, and animals that eat plants also use organic nitrogen to build protein. Nitrate is measured in milligrams per liter, and natural levels of nitrate are usually less than 1 milligram per liter. Concentrations over 10 milligrams per liter will have an effect on the freshwater aquatic environment. 10 milligrams per liter is also the maximum concentration allowed in human drinking water by the U.S. Public Health. Phosphorus. In small quantities, it is essential for plant growth and metabolic reactions in animals and plants. It is a nutrient in shorter supply in its most fresh waters, with even small amounts causing significant plant growth and having a large effect on the aquatic ecosystem. In general, concentrations over 0.05 will likely have an impact, while concentrations greater than 0.1 milligrams per liter will certainly have impact on a river.
Eutrophication is a process through which lakes, streams, or bays become overloaded with nitrogen-rich water. When this occurs, large blooms of algae and aquatic plants occur, fed by the excess nitrogen and phosphorus. Eutrophication can occur in both freshwater and saltwater. This is what happened in the Wilson Wetland.